All right, I am going to go over this 2.6 assignment because it is the review for our Unit 2 test that we will be taking on Tuesday. So we're going to briefly go over it. So just bear with me. It will be a very long video. So, all right, this first one, it wants us to find the range of each of the functions of the given domain. Guys, range isn't just another word for your y's. Okay, so this is your y values. And domain is just another word for your x values. So what it is saying, hey, find the y values for every x value you put into the function. So it gives us that the function is equal, the f of x equals 6x minus 1. Which remember, f of x is just another way of saying y equals 6x minus 1. Well, now it gives us the domain right here. This domain is just your input values, okay? Because domain is the same thing as your x, and it's the same thing as your input. So right here, we're going to do f of 0. So 6 times 0 minus 1. Remember, wherever there's an x, I'm going to put in a 0. Okay, 6 times 0 is 0, minus 1 gets you a negative 1. So the first number of our range is negative 1. F of 2, so 6 times 2 minus 1. So 6 times 2 is 12, and 12 minus 1 is 11. So our second number of our range is 11. And then f of 4, so 6 times 4 minus 1. 6 times 4 is 24, minus 1 is 23. There is the third number of our range, and we just have to double check. There's no repeats, and they're in number order, which they are, so negative 1, 11, and then 23. Okay, so when you see this, you're just inputting those domain values into the function that it gives you. Okay, so this next one, we have g of x equals 2x squared minus 6. The domain is negative 3, negative 4, and 5. Again, your domain, it's just your input, so then we can get our range values. Okay, so g of our first input is negative 3. So we have 2 times negative 3 squared minus 6. So when you put this in your calculator, make sure that you're using parentheses and that your x, or not your x, but your squared, is going on the outside of that parenthesis. Therefore, it'll actually square the negative 2, and because we want to square the negative. Okay, so speaking of, when we put that in our calculator, so negative 3 times negative 3, so negative 3 squared will give us a 9. 9 times 2, which is this right here, 9 times 2, which is 18. And then 18 minus 6 will get us 12. But again, your calculator does it all as long as you use the parentheses and put the square on the outside of the parentheses. So g of negative 4. So we have 2 times negative 4 squared minus 6. Again, we want to make sure we're multiplying the negative 4. So negative 4 times negative 4 will give us a positive 16. Positive 16 times 2 will get us 32. 32, and then 32 minus 6 will get us a 26. So again, our first two range values is 12 and then 26. Then our last one is g of 5. So 2 times 5 squared minus 6. 5 squared is 25. 5 times 5 is 25. 25 times 2 is 50. 50 minus 6 will get us a 44. So our last number of our range is 44. All right. The next section, it says if f of x equals 3x minus 1 and g of x equals x squared plus 1, find the following. So remember, we did this on the first day of function notation. It says f of 3, so you're going to use function f, okay? but you're going to plug in 3 for x. So if it's f of 3, I'm going to do 3x minus 1. I'm going to use that function. But when I see that x, I'm going to plug in a 3. So 3 times 3 is 9. 9 minus 1 is 8. So 8 will be your answer. And if we wanted to make like an ordered pair for this, it would be 3 comma 8. But we didn't have to. But we just had to find what the actual y value was for this one. All right, this next one says g of 3. So I'm going to use the g of x, x squared plus 1. Okay, so g of 3. But wherever there is an x, I'm going to put a 3. So 3 times 3 is 9. 9 plus 1. G of 3 equals 10. So again, if we wanted to write an ordered pair, it would be 3 comma 10. All right, what if we have something like this, where it's f of negative 1 plus g of 4? So what we have to do here is you just have to plug in the functions separately, and then we're going to take both of our values and just add them in the end, okay? So we're going to do f of negative 1 here, and then g of 4 here, just so we can keep them separate where we don't get confused. So f of negative 1, I'm going to take my f function, okay, which is 3x minus 1, and I'm going to plug in a negative 1 instead. So 3 times negative 1 will get us a negative 3. Negative 3 minus 1 will get us a negative 4. So our first answer of our function is negative 4. G of 4, I'm going to take my g function and plug in my 4 for the x. So the g of x is x squared plus 1. So instead of x squared, it's going to be 4 squared plus 1. 4 times 4 is 16. 16 plus 1 will get us 17. Okay. So now we have two of our answers. We have negative 4 and then we have 17, but there is a addition sign in between them. So my answer is the negative 4 plus 17. And that answer is 13. So when we did f of negative 1 and g of 4, when we added them together, we got our answer as 13. So you just kind of have to take them in parts and then just come together with the operation of addition in the middle and just add your answers. So that's going to be the same thing for number 6, but now number 6 we're going to subtract. Okay, so again, we're going to do g of negative 4 here. And we have f of negative 2 here. And then in the end, we're going to subtract them. So g of negative 4, so the function of g of x is x squared plus 1. So instead of x squared, it's going to be negative 4 squared plus 1. So again, use the parentheses, make sure the squared goes outside of the parentheses. So negative 4 times negative 4 is 16. 16 plus 1 gets us 17. F of negative 2, so we're going to use the function of f, and it's 3x minus 1. So instead of 3x minus 1, it's going to be 3 times negative 2 minus 1. 3 times negative 2 will get us a negative 6. Negative 6 minus 1 will get us a negative 7. And like I said, in the end, we're going to take that operation of subtraction, and we're going to subtract 17 and negative 7. Okay. When we do that, we get a positive 24. All right. We have for g equals negative 5, negative 5, 2, negative 4, negative 1, 3, negative 8, negative 2, 0, and 4, negative 9. Find the indicated values. Okay, so right now I have g of negative 4. So what this means is when x equals negative 4, what is y? And I know that because if we're looking at our function g of x, that negative 4 replaced that x. So I'm going to look through all of my x values. So negative 5, negative 4, 3, negative 2, and 4. And I'm looking for the correct y value. So our negative 4 is here, and its y value is negative 1. So our answer is negative 1. So same thing over here, we have g of 4. So when x equals 4, what is y? So I'm looking for my x values where x will equal 4 and my y value is negative 9. So those should be give me questions. I'm just going to tell you right now. All right. So it says use the graph below to answer the questions that follow. Okay, so we're going to list all of the ordered pairs. So I went through on my review and I actually put the ordered pairs on the graph. So in this one we have negative 7, 0, which makes it kind of hard to see. Let's make it a little bit thicker. This one is at negative 6, 5. And by the way, I know these because I'm counting from the origin, guys, and I'm counting left to the point and then I'll go up. Or if I just go left and it stops, left and then down. Remember, we have to go side to side first before we can go up and down. I like to say we like to run before we can jump. So it's like doing triple jump or like hurdles in track. So you got to run, and then you can jump up, okay? Like pole vaulting, all right? So I know we often get those confused, but you must run before you can jump. This one down here is at negative 5, negative 3. This one's at negative 1, 2. This one's at 1, 6. This one's at 5, 3. This one's at 2, negative 2. And the last but not least, we have 7, negative 8. Okay, so I want you to list those here, but I'm not going to relist them because I don't want to waste time. But all of those points on your answer should go right here, okay? Domain. Guys, your domain is all your x values. Okay, it's all your x values, but it's from the furthest left to the right. Okay, because remember when we list our domain, we have to do least to greatest. And the further left you go, the smaller that number is. So I'm going from left to right with the domain. So domain is your x value, your x coordinate. So I'm going from left and I'm going to the right. Okay. So when I write my domain, I'm looking for my x value. So the furthest left point is negative 7. And by the way, we want to make sure that we do not repeat. Okay, do not repeat your values. The next one is negative 6. Notice how I'm going from the furthest left point. I'm going to keep going to the right. Okay, the next point is negative 5. The next point is at negative 1, this point right there. The next point is at 1. Next point is at 2. We have one at 5. And then last but not least, we have our 7. Okay. All right, this function is a discrete function, and the reason why it's a discrete function is because it has points only, okay? We can label all of the points, okay? If it gives you ordered pairs or just single points only, then it is a discrete function. Therefore, we can list all of the domain and range individually, okay? So the range of this, guys, is your y values. Okay, this one is from bottom to top. but still least to greatest. But that makes sense because the most bottom numbers, the ones on the furthest, like closest to the end of the graph, are going to be your smaller numbers. The lower it gets, the smaller it gets. Okay, so when we are talking about our range, okay, it is from bottom to top. So when I mark off which of my range I'm doing, I'm going to start from the lowest number. And the lowest point I have is at that -8 on my y-axis. And my y-axis, guys, is this one right here. And this is what I'm paying attention to when it comes to numbers. The next one is at -3. And again, we're going to make sure we do not repeat. The next one up is at -2. Then we have a 0. We have a 2. We have a 3. And notice how I'm just going up the ladder. We have our 5. And then last but not least, we have a 6. Okay, so it was bottom to top. I went from the bottom of the graph and I went all the way up. Remember, domain is like reading a book. You got to read left to right. But range is like climbing a ladder, riding an elevator, being on the Superman. You start at the bottom and you go to the top. Okay, is this relation a function? Yes. Okay, and it's because all x values are unique. All right, so this next part, 13 through 16, can get a little confusing, but I'm going to try to help you through this. All right, so we have f of -1. So again, if we have a function and it's f of x, that's -1, replace the x. Therefore, this means that when x equals -1, what is y? So what that means is I'm going to look at my x-axis and I'm looking for a point that lies on -1 on the x-axis. So -1 on the x-axis is this one right here. So I'm looking at this line right here for a point. And there's a point right here. Okay? That's when x equals -1. Well, when x equals -1, our y value is 2. So y equals 2. So again, f of 7, so x equals 7. What is y? So again, I'm going to look at the x-axis because it's x equals 7. And I'm looking for when it hits a +7. So +7 on our graph is right here. Let me draw. And it hits a point right here on that x equals 7. And when x equals 7, our y value is -8. All right, this next one, it says f of x equals 3. Well, remember, f of x is just another way of saying y. So this is, hey, when y equals 3, what is x? So now I'm changing my focus to the y-axis, okay? And I'm saying, hey, when we are on the y-axis, is there a point that hits +3? So I'm going to +3 on the y-axis, and I hit a point right here. So when y equals 3, my x equals 5. So again, right here, y equals 6. What is x? Because y equals 6, I'm going to look on the y-axis for 6, a +6. So 1, 2, 3, 4, 5, 6. We hit a point right here. And so when y is 6, x is 1. All right, last but not least, we have domain and range. Okay, so we're going to go ahead and highlight both of these. These are continuous. And they are continuous because they're both lines. Okay? So here's how I tackle these. Okay? Domain. It does not matter. It's still left to right. Okay? All right. So when I see a line with points, I'm going to go ahead and label the points, the two endpoints. So we have a 1, 2, 3, 1, 2, 3, 4. So we have a -3, -4 point here, and then 1, 2, 3, and then 1, 2, 3, 4, 5. Okay, so 3, 5. Okay, so when we do our domain, it is still the same. Okay, it is our x values. Okay, but when we write our domain and range in interval notation, which we're going to write in interval notation because this is a continuous function. So when it's continuous, you have to use interval notation. So when we are writing interval notation, remember your smallest number gets listed first. So domain is your x value. So luckily for us, because this is a line and it's not curvy and it's not funky, I can use my endpoints as my domain and range. Okay, so domain is the furthest left of the graph gets. So the furthest left this graph gets is right here at this point. So that is -3. So -3 will get listed first. Okay. Our interval notation, okay, will always face the same way. It'll always face going away, okay? Like the mouth opens to the right, okay? All right. And then we put our furthest right point, okay, which is 3. Okay, so we have the furthest left on the left side and the furthest right on the right side. Now we just need to determine, do they get closed? Do they get an equal to sign? Well, because both of these are closed symbols, closed and closed here, they get an equal to sign. Our range is from bottom to top. Okay, so you're looking at the furthest bottom this graph gets. Well, luckily for us, the furthest bottom this graph gets is at this point of -4. So -4 gets listed first. Y goes in the middle, and our interval signs, inequality signs go the same direction always. Okay, and then our furthest the highest our graph gets, which luckily for us it is one of our points, is 5. So 5 goes on the other side of this interval notation. All right, for this next one, same thing, domain, furthest left. Okay, so the furthest left this point gets is 1, 2, 3, 4, -4. So -4 goes first. Okay, our inequality signs will always face the same way, and when we're talking about range, x always goes in the middle. The furthest right this point gets is -1. It's still on the left side, okay, but it is the furthest our line goes to the right. Okay, so that's going to be the right side of our inequality, so -1. Now we just need to determine who gets an equal to sign. Well, -4, if we're looking at our -4 graph, which I'm going to zoom in, it has an open sign. This open sign tells us it does not include that point. Okay, when it is open, it does not include. Okay, so because this one's a closed point, then -1 gets the equal to sign. So range is the same way, bottom to top. So we're looking at the most bottom point. Let's see, let's highlight our x's here. So the most bottom, the lowest this line goes is right here. Okay, and at that point, it is 1, 2, 3, -3. Okay, so -3 gets listed first. And I know it's -3 because range is your y values. So I'm looking at it based on the y-axis. So on the y-axis, it is on -3. Okay, so I know some of us can get confused about that. But range deals with the y, so we're looking at the y-axis, and it is your y coordinate. Okay, so inequalities always face the same way. We use y because these are our y coordinates. And then we're looking at the highest our graph goes. Well, the highest our graph goes is here. Okay, which is at a +1. So 1 will go on the right side of this inequality notation, or interval notation, sorry. Okay, and then now we just need to decide which one gets the equal to sign. Well, -3 is on the closed endpoint, so -3 gets the equal to sign. Again, when we are listing our domain and range, it's always least to greatest. Therefore, on every single one of our interval notations, the lowest number got listed first. It is the one on the left. And remember, our inequalities always face the same way. Okay, domain is like reading a book, left to right. Range is like riding the Superman at Six Flags, bottom to top, or riding an elevator, or climbing a ladder, bottom to top. Okay, so you just have to go back and ask yourself, okay, is this, when we're talking about domain, is this the furthest left this graph goes? Is this the furthest right? But when we're talking about range, we just think, okay, is this the bottom of the graph? Or does our graph get below our end point? Because if it gets below our end point, we need to go to that pretty much rock bottom of that graph, more so than just our end point. So if this graph went up and then down, then our bottom of our graph would be down here, not right here anymore. Okay, so just be mindful of that when you're making your range on your test. Okay, and then you're looking for the highest our graph goes, and sometimes it's going to go above, and then but our end point ends here, but the tallest it gets is up here. So you just have to ask yourself, is this the lowest the graph goes versus is this the highest the graph goes? And so I hope going over each one of these will help you for your test. If you have any questions, I will be ready to answer those before we take our test. So have those questions ready for us before we get the test started. All right, bye guys.